Welcome to The Explainer. Today we're going to dive into a really fascinating and maybe a little brain-bending theory from Ben Goertzel. It tries to tackle a huge question. What actually is science? Is it this neat and tidy system of rules, or is it something a lot messier?
So, here's how we're going to break this all down. First, we'll look at the classic debate that got us here in the first place. Then, we'll unpack Goertzel's big idea, this thing called cultural/pragmatic probabilism. We'll explore its three core components, see how they can actually explain scientific revolutions, and then wrap up with the really wild part, how this could be a blueprint for an AI scientist.
All right, so first things first. To really get what Goertzel is proposing, you have to understand the problem he's trying to solve. For, decades, the whole philosophy of science has been stuck in this giant tug-of-war between two totally opposite ideas.
In one corner, you've got the rule makers, thinkers like Karl Popper. They believed science had to have strict, formal rules, like falsification, to separate it from everything else. But in the other corner, you have the anarchists, like Paul Feyerabend. He looked at the real, chaotic history of science and said, nope, the only rule is anything goes.
Now, Goertzel, he was a big fan of Feyerabend's whole creative, messy view of science. But he felt that anything goes just wasn't the full picture. I mean, if that's the only rule, what makes science any different from art or poetry or anything else? There had to be something more to it.
And this is where his new idea comes into play. He calls it cultural/pragmatic probabilism. Yeah, I know, it's a mouthful. Let's just call it CPP. It's his attempt to find a middle path between those two extremes of rigid rules and total chaos.
So what is CPP? Well, the core idea is that we should judge a scientific theory based on three things, not just one. It's not just about how well it matches the data. It's also about how simple it seems to the people using it, and, whether it's actually useful for anything.
Okay, this sentence right here, this is the absolute heart of the entire theory. CPP says that the best science is actually weak science. And weak here doesn't mean flimsy. It means a theory is elegant and simple. It's a theory that just refuses to overcomplicate things by making distinctions that don't really need to be there.
So the big question is, how do you measure this weakness? How do you know if a theory is making unnecessary distinctions? Well, Goertzel says you check it through what he calls the three weakness channels.
And those three channels are evidential, cultural, and pragmatic weakness. Let's just quickly break down what each of these really means.
First up, we have evidential weakness. This is the one that probably feels most familiar to all of us. It's the classic scientific principle. Don't overfit your data. If you can explain something simply, don't invent a super complicated theory just because you can. Stick to what the evidence actually supports.
Second, there's cultural weakness. You can think of this as a super flexible version of Occam's razor. It's all about simplicity, but here's the twist. What's simple totally depends on the scientific culture you're in. For a quantum physicist, Hilbert spaces are simple. They're the basic building blocks. For you and me, they're ridiculously complex. Simplicity is all relative.
And last, you've got pragmatic weakness. This one is all about usefulness. It basically asks, does this detail actually matter in the real world? If two different ideas in a theory lead to the exact same action with the exact same result, then a good, weak theory just treats them as the same thing. No need to split hairs if it doesn't change anything. Okay, so this is where it gets really, really cool. Because when you put these three channels together, you get this incredible framework for explaining those massive, earth-shattering moments in science, the paradigm shifts. Just think about that huge jump from classical physics to quantum physics. The weird experimental data didn't just appear overnight. What changed was the culture of physics. For classical physicists, quantum effects were these weird, complicated add-ons. They were expensive to explain. But once the new paradigm took over, things like Hilbert spaces became the simple, cheap, native language. Suddenly, quantum theory was the weaker, more elegant way to see the world.
So what this means is that a scientific revolution isn't just some random lightning bolt of genius. It's actually a predictable shift in what a community decides is simple, what it decides is useful, and what it decides is good enough evidence.
And that brings us to the final piece of the puzzle. And honestly, the part that sounds most like science fiction. What if you could use this entire framework as a blueprint to build an artificial intelligence that can actually do science?
Goertzel lays out this three-tiered structure for an AI scientist, where each level gets progressively more powerful and creative.
So Tier 1 is like a referee.
It's a validator that just checks if new ideas fit the current rules. Tier 2 is the discoverer. This is your workhorse AI, doing normal science and finding the best new theories within the existing game. But Tier 3 is the holy grail. It's the innovator. This AI doesn't just play the game, it invents a whole new game. It would be an AI Einstein, creating new concepts from scratch.
And that, right there, gives us a whole new way to think about what true genius is. Radical innovation isn't just about finding a new answer inside the box. It's about learning to build a completely new box, a new way of defining what simple and relevant even mean.
So I'll leave you with this pretty mind-bending thought. If the whole history of science is about getting better and better at throwing out unnecessary complications, what are we overcomplicating right now? What cherished, complex ideas in today's science will a future, weaker theory look back on and see as just obvious clutter?